So this is our last example. Seems like each section in chapter 1 is getting shorter. Like we had 25 videos in the first one, and now we're down to like 7. Okay, complex rational expressions. That's when you have fractions within fractions, kind of. So you might have something like a over b plus, b over c all over 3 over b, or something like that. So you have like fractions in the numerator, or rational expressions, I should say, and you can have them in the denominator as well. So you get this kind of complex situation. Now for these types of problems, we usually teach 2 methods. Your book only shows 1, and so I'm just going to show you the 1 method. It's a fine method, and then you don't have to decide, oh, what method should I use? What they have us do is, if there's more than 1 term, meaning there's adding or subtracting in the numerator, you're going to combine terms in the numerator so that you just have 1 rational expression. Then you're going to combine terms in the denominator, so you only have 1, denominator, so you only have 1 rational expression. And then you're going to use the rule for division. Use the rule for division, which is keep, change, flip, that one. Okay, and I'll show you how this all looks, but that's the idea. Okay, so here's our example. We've got, I'm going to write a little bit bigger, y plus 1 over x. That's my numerator, and I want to combine those. Right now, I have 2 terms, and I want it to be 1 rational expression. So think of that y as being over 1, and then the LCD would be x. So you're going to multiply by x, and then you're going to get xy plus 1 over x. Now it's just 1 rational expression. Okay, so this is going to be my numerator. Hopefully that makes some sense. The denominator, that's already just 1 rational expression, so I don't have to do any adding or subtracting. Now when you're writing these, you want to make sure you know which line is the separator, right? Like which one is separating the numerator from the denominator, because sometimes that can be a little tricky. Okay, so I tried to draw it thick there for you. Okay, so we have 1 rational expression in the numerator. We have 1 rational expression in the denominator. So this is division, right? This is like the division bar. So we're going to keep the numerator, xy plus 1 over x. We're going to change it to multiplication, and then we've got to take this one and flip it. So it's going to be y over x. Okay? Now, I don't see anything that cancels. So I'm going to have y times xy plus 1 over x times x is x squared. And I would just leave it that way. Okay. So the idea is do your adding or subtracting in the numerator, and if you have to in the denominator, do it in the denominator. And then you can think about it as a division problem. Keep the numerator, change it to multiplication, and then flip that denominator over. And then now it's a multiplication problem. We didn't have anything that would cancel that time, so that's too bad. But those things happen.